Okay. All right, E is a number pretty close to 3. Now, what's pi number pretty close to? 3. Both of those are irrational numbers. So what that means is the decimal representation of them never stops, and it doesn't repeat. So, which I think it's fascinating that 1 happens to be a little bigger than 3, and 1 happens to be a little what? Smaller than 3. But when you're thinking mentally, think it's around 3, a little less than 3. So there's nothing magical about it. I mean, when I'm seeing something like E squared or E cubed, in my mind, I'm thinking E squared would be pretty close to what number? 9. Would it be bigger than 9 or smaller than 9? A little smaller, because E is a little smaller than 3. Same thing here. What's E cubed going to be fairly close to? 27. And again, it's going to be a little bigger, a little smaller. But now pi cubed will be close to 27, but it would be what? Okay? So you can kind of rationalize some things. A lot of times on like an MCAT or a grad test, when you're not allowed to have a calculator, that's the kind of thing they're going to expect you to be able to do. In other words, it's multiple choice, so they're going to give you 4 answers, but only one of them is going to be remotely possible. Is everybody with me? So for you to pick like 8 for this or that, it's not going to make me. I'm saying like you got to be careful. So just trying to make sure you understand some things. Now, we talked about last time what the graph looks like. All right. So it's nothing magical. All right. So if I do y equals e to the x, I mean, if I'm making like a t-table, e to the 0, what's any number to the 0 except 0 to the 0? 1, isn't it? So 0, 1's on my graph. All right, what about a 1? That'd be e to the first, wouldn't it? Now we've already said that e is about what? 2 point what? 71, right? So when I go over 1, I'm not going to quite be up to a 3. Now what if I had a negative 1? E to the negative 1. Wouldn't that be 1 over e? So what fraction is that pretty close to? About 1 what? Third. So when you start making the graph, it looks like this. That's what happens when you do your graph. Now, have you ever dealt with logs? All right, now somehow I do not understand why. Some high schools don't do them much anymore, but you're going to need them for several things in science and math. Now, the one that you're probably most familiar with is something like base 10. Okay, so when there's not a base showing, it's understood to be base 10. Now, you can have other bases. Now, most people don't think very well in logs. They think better in exponents. So here's what I need you to understand. I know what the answer is to this without my calculator. It's 3. Because in my mind, I change it from a log problem to an exponential problem. Okay? Means that b to the r equals a. There are 2 ways of saying the same thing. So here, I didn't miraculously think in logs. I thought, in my mind, I turned it into a problem with exponents. 10 raised to some power has to equal what? 1,000. See, that's what that means. All right. What's this big number called when you write it like this? Base. See, that's your base. That's the base of your log. That's the reason it's called the base. All right. This answer is your exponent, and this thing right here is basically what you think of as the answer. So in my mind, I'm thinking, what do you raise 10 to get 1,000? 3. All right. What's this answer? It's also 3. because 2 raised to something is 8, and we know it's a 3. Is everybody with me? Now, what would be the problem if I did this? All right, go ahead and pull your calculators out if you don't have them out. Because again, this is the kind of thing they would stick on a standardized test. Now, when there's not a base showing, what's it understood to be? So what's the equivalent exponential problem to this? 10 to something has to equal what? 16. Well, in my mind, I start thinking, okay, what's 10 to the first? What's 10 to the second? 100. Wouldn't 16 be between those two things? Which one would it be closer to, 10 or 100? It's a whole lot closer to what? 10. So this answer is a number between what? 1 and 2. Which one is it a whole lot closer to? 1. So take your calculator and go find me this answer. What's the log of 16? You see what I'm saying? So most of the time, logs don't come out to be pretty integers. They come out to be long decimal numbers, and that's the reason why. So what if I ask you this? Now, what's the equivalent exponential problem? 5 raised to what? Something is what? 100. All right, think about it for a minute and try to narrow down. Don't say anything yet. Think about what 2 integers that question mark would have to be between. What 2 integers is the answer between?
2 and 3.
Everybody see why it's 2 and 3? Because 5 to the second's what number? 25. What's 5 to the third? 125. And this answer is between there. So 5 to some number has to be between those two. Now, is 100 closer to 125 or to 25? Closer to 25. Is everybody with me? So it's going to be between 2.5 and 3. Is everybody with me? And you can go to your calculator and check it. Now, the one that most people don't, I don't know why we don't know this, is this one. What's my base? E. Now, what's the equivalent exponential problem? E raised to something's going to be what? 6. Now, remind me what E's pretty close to. 3, right? It's a little smaller than 3, right? So in your mind, as you think like 3 to the first, what's that number going to be? It's going to be 3, isn't it? Now, that's not quite true because this number is not quite 3. Is everybody with me? What's 3 to the second going to be? 9. And this number is between those two, isn't it? So you're expecting your answer to be somewhere between 1 and what? 2. Now, rarely do you see it written log with the base of b. You see it written like this. Log with the base of b is natural log. That's all natural log means. Log with the base of what? E. So you've got a button on your machine. What is the natural log of 6? See, closer to 9 than to 3. Everybody with me? So closer to 2 than to what? Than to 1. Now that's why this. Everybody with me? Now you don't need your calculator for this. You can use the calculator, but you don't need it. The natural log of 1. Well, what's natural log mean? Log of the base of what? E. And what does that mean? That means E raised to something is a what? Is a 1, right? What can you raise anything to make it a 1 except 0 raised to that number? You see, punch in natural log of 1, and sure enough, what do you get? You get 0. Now, that's why this should bother you. If somebody says, what's the natural log of a -3 instead of 3? Well, look what that would be saying. That'd be saying log of E. Everybody with me? Well, now, that would mean E to something has to be a -3. What are you going to raise a positive number to end up with a negative number? What? And see, look what happens when you do your calculator, do natural log of a -3 and see what it says. What's it say? Not happening. So depending on your version, it may say error, it may say domain problem, it may say no real number, depending on what version you've got. Is everybody with me? What if you say natural log of 0? What's it going to do? Again, what? Domain error. You can't raise a positive number to something and make it 0. Now, I need you to go graph natural log for me. Okay. Now, we already said, what's the natural log of 1? You told me the natural log of 1 was what? 0, wasn't it? Got your graph? Does it look like this? Right? Now, mentally, I need you to do the line y equals x. And fold. And what do you notice about this blue graph and that orange graph? What are they going to do? They're going to be on top of each other, which means they're inverses. These are inverses of each other. Now think about why. Aren't you feeding in basically A's and getting out R's? Over here, what are you feeding in? R's and getting out what? A's. See, the domains and ranges get what? Switch. Now, we talked about this last time. You can basically use common sense so you can memorize some stuff. All right, look at the orange graph again. That's e to the x, right? What's the domain on that orange graph? All real numbers. All right, if I'm on the orange one, my domain is all real numbers. What's my range on the orange one? What about the y values? 0 to infinity. Now, do I need a parenthesis or a bracket around the 0? Parenthesis, because that means it doesn't get there. It doesn't ever touch it, right? What about x-intercept on the orange one? Do I have an x-intercept to touch the x-axis? None. Do I have a y-intercept?
Yes.
Yeah, what is it?
0,
0, 1. Is the function 1 to 1?
Yes.
Now, look at the blue graph. Just look at the graph. Okay, on the blue graph, what's your domain?
0. Yeah.
You don't have any x values over here, do you? So my domain is what? Isn't it 0 to infinity? Now, does it ever touch this? In other words, do I ever have any point when x is 0? I don't, do I? So that means that's a parenthesis. What's my range? Look at your y values. Do you have negative y values?
Yes.
Yeah, you got a 0 for a y value. You got positive y values. So what's your range on the blue one? It's what? All real numbers. All right, on the blue graph, on the log graph, you have an x-intercept. Isn't it 1, 0? What about your y-intercept on that blue graph? I don't have any. Is it 1 to 1? Now, look at them. They're inverses. What happens to the domain here? It turns into what? The range over there. I mean, like that, so you know, everybody with me? And the range over here turns into the domain. If the point 0, 1's on this graph, that's going to imply the point's what over there? 1, 0. So you can memorize the information they give you in your book, or you can just use common sense and get it. Okay? Now, there are 3 log rules I need you to memorize. You're going to make your life an algebraic nightmare later. Okay? And none of us like algebraic nightmares. Okay? Now, your book has them written for natural log, but they really work for any base. It's just your book tends to use natural log as the most common base. All right? And you need the calculators out because you have to verify some things for me. All right, first we're going to write them down, then we're going to make sure you understand what they're saying. The log of AB. Now, when there's nothing between them, what am I doing? Multiplying them. Okay? It is not the natural log of A times the natural log of B. It's the natural log of A plus the natural log of B, which is not intuitive to me. It might be intuitive to you. Okay? A second rule that you've got to memorize is the natural log of the fraction A over B. And again, that is not going to be the natural log of the numerator divided by the natural log of the denominator. That seems to be more intuitive. It doesn't work. It's the natural log of the numerator minus the natural log of that denominator. And then the third rule that you've got to learn is the natural log of like A to the R. That is R times the natural log of A. Now I'm going to use numbers to illustrate it, but later they're just going to use variables. So when we start doing derivatives later, when you're taking the derivative of the natural log later, if you don't rewrite it using these rules, you're going to have this really complex fraction where the numerator is a fraction, the denominator is a fraction. You've got to simplify this algebraic fraction over this other algebraic fraction. Bad. If you learn these rules, easy. Okay? So you can either learn it now and slide later, or slide now and pay the bill. Everybody with me? Now, here's what I mean. Natural log of 6. Now, do we agree that 6 is 2 times 3?
Yes.
Then, if you find the natural log of 2 and you add it to the natural log of 3, you better get the same thing as the natural log of what? 6. So I want you to verify it on your calculator. I want you to find the natural log of 6. And I want you to find the natural log of 2 and 3 and see if you add these, does it give you that answer? Work? All right, now, what about this one? All right, what if you have the natural log of, say, 12 divided, what if you have the natural log of, say, 3? All right. Is 3 12 divided by 4? Is that the same thing? Yes. So then, if I find the natural log of 12 and find the natural log of 4 and subtract them, I better get the same answer as what is the natural log of 3. So check that and verify that with your calculator. And see if it works. Everybody okay? Now, do we agree, natural log of 8, do we agree that 8 is 2 cubed, 2 to the 3rd? Then according to this rule, if I took the natural log of 2 and I tripled it, I'd get the same thing I got when I plugged in the natural log of 8. So again, verify that with your calculator. Everybody okay? Now, you've got to memorize these 3 rules written in black. Because for homework, what they're going to do is they're going to give you these long algebraic things and make you expand and condense them. And I'm going to show you what I mean by that. Okay? All right. So for instance, I'm going to do this real quick. I said this, expand. All right. And your directions are going to say things like, use the logarithmic properties to expand the following. Now, do you have a rule about roots?
Wait, no.
No. Everybody okay? But what can I change roots to? An exponent. I do have a rule about exponents. Okay? So what would you change that to? The natural log of 2x what? To the 1/2. Now, let's make sure we're clear about something. You see that these are not the same thing. The rule doesn't go with this one. The rule goes with this one. These are the things you got to be careful about. Okay? Now, I'm going to use one of those three rules first. Which rule am I going to use first? The third one. According to the third one, what can I do with that 1/2 power? I can bring it down. Okay. Everybody clear about what we did? We have the log of something to a power. Now, what does this 2x really mean? 2 what? Times x. Okay, which rule over there am I going to use now?
First.
All right, I'm going to use that first one now. I'm going to do something here and let you tell me what's wrong with it. Because I get this a lot. That 1/2 is times what? All of that. So I better have a what? Parenthesis or a bracket. All right, what if you had this one? You work on this one for a second. All right, which rule are we going to use first? 1, 2, or 3? 2. Okay, I got the natural log of a fraction. It's the natural log of the top of the bottom. The top plus or minus? Minus the natural log of the bottom. Everybody okay? All right, now, can I say the natural log of x squared minus 4 is the natural log of x squared minus the natural log of 4? Can you do that? Is that a rule over there? No, there's no rule about subtraction. There's a rule about a product, a quotient, and a power. Is everybody with me? Now, what's something I can do though to make myself go a little further? If I'm going to have to use a little algebra, what am I going to do? Will this thing factor? What will it factor into? All right, x plus 2, x minus 2. So what rule can I now use? 1. So that's going to be the natural log of x plus 2, what? Plus the natural log of what? X minus 2, and then minus the natural log of 3. Now, can I go further, or is that as far as I can go? That's it. So that's what I mean by expand. Is everybody okay? Now, let's go the other way. Let's condense. Now, condense means they're going to give you the right side and want you to get back to the left side. So you're going to go in reverse. All right, so what if they say this? Condense. All right, so what if they give you one that's fairly simple? So condense that. 4 times the natural log of x plus the natural log of y. So now instead of going left to right on the rule, you're going right to left on the rule. Okay? Tell me something I can do. I can use, what am I going to use with this first term? Rule number what? 3. So instead of putting 4 the natural log of x, put the natural log of x what? Now does that 4 go with the x or the whole thing? It's with the x. I've still got plus what? The natural log of y. Okay. Now what can I do? Which rule? That first one. I can change this product to the natural log of what? X to the 4th times what? Y. Is everybody okay? All right, let's do one more and then we're going to move along and finally get to calculus. I'm so excited. One half the quantity, the natural log of x minus the natural log of y. So condense that one for me. Right, you tell me what to write. What did you do first? Number 2. So what did you do? Just leave the 1/2 right there? And then put what? Natural log of what? X over y. Now what can I do? Anything? Do I have a fraction in front of the natural log? In other words, I don't really need that parenthesis technically, do I? Does that mean 1/2 times that as well? So what happens when I have something in front of natural log of something? Where does this thing go? All right, well, is it the exponent of the whole thing or the exponent of just that thing? Just that thing. Is everybody with me? So I'm going to have what? The natural log of xy. What's to the 1/2 power? Is everybody with me? We okay? Now, more than likely, they're not going to leave it that way. What are they going to change it to? Oh, I'm sorry. Thank you. Okay. Well, it's magic.
We were gonna believe you. We were gonna go with
Y'all can
it.
tell her that she knows something we don't know. Now, look back and say, believe it. All right, so do you understand what it means by condense and expand? Because what's going to happen later is when you're doing calculus later, they're going to have you do something to this. And doing it to this it's just going to be, it's not going to be hard, but it's going to be a lot of algebraic cleanup. But instead, if you turn this into this, it's not going to be a lot of algebraic cleanup. So learning those three rules now, being able to expand and condense is going to make your life a lot easier later. Is everybody with me? So it's kind of pay now or pay later. All right, everybody with me? All right, now we finally get to start calculus. All right, now, in your books, in this first section, on chapter 2, I'm not going to spend a lot of time except look at page 67 in your books for just a second. All right, they're trying to give you basically a reason to study calculus, but I do know the reason you're studying calculus is you have to. Okay, now, but they show you some things like, you had the word slope before, you had slope back in pre-algebra, but you only found slopes of lines. That's what you can do with algebra. But with calculus, you can find slopes of other curves besides lines. All right? Back in probably elementary school, you learned to find averages, like average speed or something. Well, you can do that with arithmetic, but with calculus, you can find instantaneous speed, velocity. You found tangents in geometry, but you only found tangents to circles. But with calculus, you can find tangents to any curve. So it's not that the things that you learned before weren't good, it's just you can do more with it. So I can take a curve with arithmetic and algebra and find the maximum. With a whole lot of number crunching, I can make a good estimation about what the maximum value that's going to fall out of an equation is. But it takes a lot of work. But with calculus, it takes about 30 seconds. And I'd rather take 30 seconds. Now, what we're going to talk about is the foundational thing about calculus is limits. Now, we're going to approach a limit 3 ways. Okay, we're going to approach it 2 ways today. And then next week, we're going to approach it formally. The way a mathematician would. Okay? But in my experience, it's better for me to approach it first. I'm going to call this numerically. Now, some people, in other words, some people will say tabularly. And then I'm going to look at it graphically. And then finally, I'm going to use the definition. Now, so we're kind of in section 2 too. Now, the reason I like 1 and 2 is it gives you an idea of what a limit is. But I'm going to have to tell you, when you're using 1 and 2, you're only getting good guesses. So if you want the real answer, you got to go down here. We'll do that next week. Now, here's the basic idea of a limit. All right. Suppose my goal in life, for some reason, would be to get to that screen over there, all right, that little lectern where that laptop's sitting, basically. Here's my only rule. Every time I move half my distance. So if I am, say, 16 feet from that lectern, how far do I move now? 8. All right, I'm 8 feet from the lectern. What's my next move? 4. All right, what's my next move? 2. What's my next one? 1. Let's see how good we are with fractions. What do I do now? Half. 4. Do I ever get to the lectern? No. So it is possible to get closer and closer and closer to something without ever actually what? Touching it. It's biblical. It's called sanctification. So it is possible to approach something but never arrive there. Now, so for instance, we talked about this already. If I give you y equals 6 divided by x minus 3, what number sends the whole earth and the universe in a spin to never recover from, and it's all your fault? 3. You know you're not supposed to plug in 3. But then every human has the same response. Well, how close can I get? Now, the reason I even do limits is this is my favorite thing, all right? I was at a basketball game, Mississippi State basketball game a few years back, all right? It was in the winter, it had snowed, there wasn't a big crowd, so my seats are back at the very top row. I'm poor, okay? So I'm at the very tip top, all right? Some dad who brought his little girl with him to the ball game. I don't know where mom was, but there was dad, the little girl, all right? She was about 2. And the Coliseum was pretty empty. So there weren't a lot of people in the upper section where we were, and I watched him. He let her, she had a little backpack, and she took out these cards, and I heard him. He said, you can play all on this row. You can play a few rows down. As long as I can see you, because there's not a lot of people here, we're okay. He said, do you see those boys running around down there on that floor? She said, uh-huh. He said, do you see the line that's blue that goes around that in a rectangle? Do you see that blue line? Mm-hmm. He said, you cannot go past that blue line. You know where this is going, don't you? So he said, now tell me what you can do. I can play. That's right. Where can you play? All I want, everywhere I want to, except where can you not play? Where that line is. Ball game starts. First, she's very content. She's in front of me and she's with the cards. Then she got a little bored, so she went down a little further with the card. Everybody with me? She's looking at her daddy. He's smiling and nodding. She makes her way to the end of the row, and he's smiling and nodding. And then that child just dropped that card and took off. I've never seen a 2-year-old go this fast. I mean, the steps were as tall as she was. She went straight down. He stands up and does that parent thing. You know what I'm saying? Like that's going to stop her. She gets all the way down, and she looks back at him. And then she goes, all the adults, nobody sees her. She's this tall. You know what I'm saying? He is running down the steps after her, but she's got a head start. She literally goes to the blue line and then turns around and looks at her dad. He is frozen, and he's shaking his head no. And she literally took her foot and swung it and put her toe what? Right on the line.
Oh my gosh.
Because he told her she couldn't go what? Past it. So you have been doing limits since birth. All right, so it's nothing new. Is everybody with me? So what we're trying to figure out is we know what we can't do. We're trying to figure out what happens when we get closer and closer to that evil thing that will blow the world up. All right, now, so we've got this graph right here. All right, now, let's do this one first. Y equals x minus 2 over x squared minus 4. We okay? Now, what I want you to do is make a t-table. Now, I want you to tell me a couple of values that you know you're not going to be able to use, that are going to be a disaster if you use them. 2 and what? -2. So we're going to try both. So let's try 2 first. You said 2. Okay. We agree we try to substitute in a 2. Life is over as we know it, so we're not going to do that. Now, in my mind, I'm a visual learner, so I've almost got to think of a number line with the 2 in it. So give me a number close to 2. 1 what? 1.9, all right? So I want you to take your calculator, I want you to plug in 1.9 for x here and here and get me an approximation for your y. All right, give me to the hundreds. What'd you get back out? What'd you get?
0.26.
0.26. All right, that's pretty close. Give me a number that's closer to 2.
1.9.
All right, put in 1.99. So take 1 and 99 hundredths and subtract 2, and then take 1 and 99 hundredths, square it, subtract 4, and then divide those two things. Now, let me warn you about something. When you type it in, if you're doing all that at once, you better make sure that numerator's in a parenthesis, that denominator's in parentheses. If you don't do that, it's going to do this. Is everybody with me? And I want it to do x minus 2 divided by what? All right. So what did you get when you put in 1.99? 0.25. All right. What's even closer?
1.999.
All right. Try that one. What'd you get? Point what? All right, let me ask you this. Go back up here and give me this one like with several decimal places. And give me this one with several decimal places. This is 0.25 what?
0.06.
What's this one? 0.25 what?
0.06.
Now, you can put in 1.99, right with me? You can keep doing that. What is it like this number is getting close to you? Maybe about 0.25. Now, you don't know that. You just think what? Maybe. Now, that's going this way, right? Go the other way. Give me a number that's close to 2 but bigger than 2.
2.1.
All right, 2.1. So go do 2.1 and see what you get. What did y'all get when you did 2.1?
0.2429.
1 point what?
2.2439.
By agree? Okay, give me a number a little closer to 2 than 2.1.
2.0.
All right, try 2.0. What did you get for 2.0? 1 point what?
2.31.
2.
2494.
Okay. Try one more. Try 2.001. See what happens. Get 0.24 or something.
9.
Now, do you see that when you're coming this way, you're coming down the chart, right? You're getting closer, but you're smaller. These numbers, these answers were getting smaller. What are they like? They're getting pretty close to about point what? 2.5. Now, when you came this way, your x's are decreasing. Is everybody with me? But this time the y values aren't getting smaller, they're getting a little what? Bigger. What's like you're getting close to from that way? maybe 0.25, everybody with me? Because what they're gonna say is they're gonna phrase it like this. This says on this graph, on this function, x minus 2 divided by the quantity x squared minus 4, when x is getting closer and closer to 2, is y getting close to anything? So that's what it's saying on that graph. On y equals x minus 2 over x squared minus 4, when x gets closer and closer to 2, does y get closer to something? To any value. And you decided yes, right? What's your guess? Now, if the real answer is 0.2499986, are you going to be able to figure that out? Probably what? Probably not. So do you understand what I mean by with numerically, you're getting a guess. Is everybody with me? So your guess is from the table, looks like getting close to point what? 2.5. Then go do me an answer to this question. You tell me another value that was going to kill the world was a -2, right? So go fill in this table. Now stop and think. What's a number to the left of a -2? So I need like a negative what? 2.9. Then what would be closer? A negative what? 2.99? Is that right? What's here? Right? So am I getting this way? Because I get this a lot on the table. Is this right? No. What needs to be here? A negative what? 2 point what? 1. Negative 2 point what? Right with me? You need to think about it. Think about it. You got to be going this way. So I'm progressively getting closer to a -2 from the left. What about over here? What's going to be close on this side? Negative what? 1 point what? 9. Negative 1 point what? Everybody with me? So fill in that table and see what you think the answer is going to be. Now, you do know that you can go into that y equals and type it in. And then go over there to your table and just change it from auto to ask. And make the calculator do all the work. So you work on that table while I go draw something over here real quick. What y'all get with a negative 2 and 1/10?
0.47.
0.475?
8.
Or give me one more.
8.
All right, what'd you get with a negative 2.01?
0.498.
What about here?
0.499.
All right, what about down here? What'd you get for a negative 1.9?
0.512.
Point what?
51.
512. What about negative 1.99?
0.5012.
So are you guessing you're good an answer to that? Does everybody agree? Some of y'all are just looking at me kind of, does everybody get that? Yes, no? All right. I want you for homework, do this. I want you to compare, I want you to do a table with this one and a table with this one and give me your guess to this answer and give me your guess to this answer. Is everybody okay? Now, I want you to look over here for a second at graphical. All right, so double check this one for homework and double check this one and see if you agree. So you think you're getting a 0.25 here, and some of y'all are thinking you're getting here a point what? Getting 0.5? Okay. That's not what I got when I did it. So double check your things. Tell me what somebody else got on this one. You got what? Negative 10 or positive 10? Negative 10. All right, so some people said they got negative 10 here. Okay. What did you get on this one? That's more what I got. What did you get here? So remember what I said, if you don't have this thing in a parenthesis and this thing in a parenthesis, that calculator's not going to do it right. What did you get down here for this one on the negative 1.9? What did we get? 10. Okay, what did you get for this one? Everybody okay? So you need to decide for homework tonight. I want you to decide what do you think the red numbers are more right or the black numbers are more right? Okay, I got more like the red numbers. Everybody with me? So for some of you, if you got the black numbers, you think this is your answer. If you've got the red numbers, what do you think the answer is? Are you getting close to anything? No. So you would say what? There's no answer, correct? So I need you to double check and play with your calculators and make sure you're okay because I'm about to do tables. Everybody with me? So if the table's not right, the answer is what? Not right. So I need you just to go do them by hand if you have to. Everybody with me? So get this answer and save it. Get this answer and save it and do what with those two answers? Divide them. Is everybody with me? Because some of y'all think when you're trying to make the calculator do all of it at once, you're keying it in wrong. All right, so double check the tables. Now, what about graphically? All right, I'm going to give you some problems like this other board for homework. Here, you don't know what your function is. So you can't make a table. So what are you going to have to do? Well, you're going to have to do it from the picture, from the graph. Now let's make sure we understand the difference in these two things. F at 1, F at, let's do this. Let me fix one thing real quick. Let's put an open hole right there. Because that's what I would probably do on your test. Okay. F at negative 1. Let's do F at 2. As opposed to the limit of f of x as x approaches 1. Or the limit of f of x as x approaches a negative 1. Or the limit of f of x as x approaches 2. Now, there's a big difference between number 1 and number 4. When I say f at 1, that means x is exactly what number? 1. That's all it is. You're looking at one spot on the graph. So that's saying on that graph, when x is 1, what is the y value? What's it like it would be? 2? Now, when I'm at 1, what's that open hole mean? It means there's a hole there. There's nothing there, right? But when I look up, isn't that point on the graph? What do the coordinates of that point look like it might be? About 1 what? 2. You might say, I think it's about 1 comma 2.1. I don't know. Again, you're giving an estimate. Is everybody with me? So you're thinking, I think around 2. Somebody else might say, well, I think about 2 and 1/10. I don't know. Either one of those seem reasonable to me. Okay. What about f at -1? Now again, what's that mean? I got an open hole, so there's nothing there, right? But isn't that point on the graph? What do the coordinates of that point look like it's about? -1 comma what? -1 or -1.1. I don't know. You see what I'm saying? You're just giving me an estimate. What about f at 2? When x is 2, what does your y value look like it's pretty close to? 0. Okay, that's reasonable. You might say, well, actually, I think it's a little above that. I think it's about 0.15. Okay. You can't tell with the naked eye. Now, I want you to look at the difference at number 1 and number 4. Do you understand on number 4, it's guaranteeing you that you never get to 1. You never get there. But it's asking you, the closer you get is y getting close to anything. Everybody with me? So here's what I would do if it were me. Do we agree that that's pretty close to 1? All right. Isn't that your point right there? What's the height of that one if you were guessing? What would you guess it's pretty close to? 0.7? Okay, now you'll see me do this sometimes. I do better when I kind of go right there. Does that make sense? I'm just trying to get the height. Do we agree that that's closer? That's closer. Now my point's a little higher, isn't it? What do you think the y value right there would be? If this is 0.7, what do you think that one may be? Point what? 8, 0.9? You see what I'm saying? I don't know. Get closer. Get closer. You see what I'm saying? What does it look like your y? Is your y value getting bigger or smaller the closer you get to 1? Bigger. What's it like it's getting real close to? 1. But it only came from which side? The left. I've also got to come from the right. So I'm starting over. I'll put my graph back. All right. What if I'm bigger than 1? If I'm bigger than 1, that's about right there. Don't you have a point right there? What do you think that y value might be, about 0.6 or something? Now, if I'm getting closer, am I going to move left or right this time to get closer to 1? Left. That's a little closer. Is that y value getting bigger or smaller? Bigger. It's getting what? What's it like you're getting close to that way? All right, so from the left side, you got close to 1, and from the right side, you got close to what? So what do you think the answer might be there? Yeah, is that remotely what you got up here? No. What happens at the numbers got nothing to do with the limit. They are 2 separate questions. Now, they might be the same, but apparently what? They might what? They might not. Now, look at this one real quick, because it's about time to go. Look what happens when I'm getting close to -1. So now I'm talking about number 5 down there. Do we agree that that's pretty close to -1? In your graph up here?
Yep.
All right. So what's the y value on that graph? 1.4, okay. Now, am I going to move right or left to get closer to -1? If I go to the left, I'm getting closer to -2. I'm going to move to the what?
Right.
To the right. Is that closer than -1? There's your point now. What's the y value on that one? Okay, 1.7, 1.8. Isn't that even closer? What's it like your y value is getting close to? 2. Okay, so remember that or write it down. Now, you got to do the same thing from the other side. Isn't that pretty close to -1? But your graph's not up here. Where's your graph? It's down here. So what's the y value on that point? Negative point what? Maybe 8, okay. Am I going to move right or left to get closer to -1? Left. So that's closer. Okay, there's the y value. What's that pretty close to? What'd you get like close to there? -1, -1.1. Is everybody with me? Did you get the same answer both sides? No. So what does it mean about this one? No limit. Empty set. No solution. You got to get the same number coming from the left that you get from the what?
Right.
From the right. So that's doing limits tabularly or numerically, and that's doing limits graphically. So your homework's going to be a little bit longer than usual. Everybody with me? You're going to do some expanding and condensing with laws. Then I'm going to give you some problems to make tables. Get guesses from the tables. And again, if these red numbers are correct, I'm not getting the same number this way as I'm getting that way. Is everybody with me? And then you're going to have a picture like this to answer a bunch of questions off of. All right. Where will your homework be? Okay. Come see me if you need some help.